Hi, my name is Delaney Hardikoff, and my research was about the different supplements that can be added into cow feed in order to reduce methane emissions at a lower cost. So, as most of us know, global warming has become an increasingly important topic throughout our society, and it's primarily caused by the emission of greenhouse gases, and it affects almost every living thing on Earth. And as we try to think of different ways we can help to mitigate climate change and the effects it has on us, we often think of doing things such as taking shorter showers or carpooling with others to reduce gas emissions or even walking places instead of driving, when in reality all these issues that we may focus on as a society are not the only ones that are negatively impacting our environment. For instance, the livestock industry is one of the biggest contributors towards global warming in our society today, and it's actually been found that the amount of methane produced by 2 cows in the time span of 1 year is actually equivalent to the amount of carbon dioxide produced by 1 car in the same amount of time. And it just comes to show that the issues that we may be focusing on as a society are not the only ones that are having negative impacts on our environment. So as I said before, global warming has become an increasingly important topic throughout our society, and it's primarily caused by the emission of greenhouse gases, and these include carbon dioxide, methane, and nitrous oxide. And from recent studies, it's actually been shown that methane is the most significant greenhouse gas out of the 3 because it's the most effective at trapping heat in the atmosphere, and it's actually been found to be over 30% more effective than carbon dioxide and nitrous oxide. So when you focus in on all the different factors that contribute to methane emissions in our society, the livestock industry is actually the most important, and we should be focusing more on it because it actually emits over 1/4 of all methane in our atmosphere today, which is extremely significant compared to other issues that we may be focusing on more. And when we also focus in on the animals used by the livestock industry and how much methane they emit, the cow is the most significant because they actually produce over 66 to 132 gallons of methane per day, which is extremely high compared to the other animals used. So just to give some insight as to how cows actually produce their methane, this picture shows the process of the enteric fermentation in the large intestine. And as you can tell, the first yellow line shows the food being ingested by the cow, which goes into the first stomach, which is the rumen. And after that, it goes into the large intestine, which is where enteric fermentation occurs. And in this process, they use a very high amount of feed energy, and the hydrogen molecules and methanogens react with one another and release methane as a byproduct, which is shown in the red arrow, and it continues to build up in the atmosphere and trap heat. So because of this issue that cows are producing such high amounts of methane in our society, scientists have been trying to figure out different types of supplements that can be incorporated into cow feed in order to react differently during this enteric fermentation process and therefore release less methane into the atmosphere. And so far, they've found 2 different supplements that have been tested and proven to decrease methane emissions, and these include the red algae Asparagopsis taxiformis and the chemical 3-nitrooxypropanol. And now that we know both are successful at reducing methane emissions, I wanted to see which one was the more practical supplement that can be used by livestock farmers and managers. So the first study that I analyzed regarding supplements in cow feed had to do with the red algae Asparagopsis taxiformis, which is shown in the photo to the right. And in this study done by the American Journal of Plant Sciences, they fed a certain amount of cows different types of algae in their feeds. And after the cows ingested it and digested it, they recorded the amount of methane produced by each cow. And it was found that the Asparagopsis supplement was the most effective at decreasing methane emissions because it had a methane reduction rate of almost 26 to 29%, which is extremely significant compared to the other algae. And the second study that I analyzed regarding supplements in cow feed, the second study that I analyzed regarding supplements in cow feed had to do with the chemical 3-nitrooxypropanol, also known as 3-NOP for short, and that's shown in the photo to the right. And in this study done by the National Academy of Sciences of the United States of America, they ran a 72-hour study where they fed a certain amount of cows different amounts of this chemical, and after the cows ingested it and digested it, they recorded the amount of methane that each cow produced, and the 3-NOP was found to have a 20 to 29% methane reduction rate, which is also very similar to that of Asparagopsis and was very effective. So now that we know that both of these supplements are able to reduce methane emissions at a high rate, I wanted to see which one would be the most practical supplement for farmers and livestock managers to use at lower cost. So for my research, I used the meta-analysis research design, and I chose this design because I wouldn't have been able to obtain all the necessary materials needed or tools to measure the methane emissions from cows. And I obviously wouldn't have been able to test on actual living cows because that type of research would have been immoral for this project. And so for my meta-analysis, I had to compare the results of various different studies regarding the methane emissions from the cows who ate both the supplements and the cost of each of these supplements per unit. So along with the databases that I previously mentioned, I also had to use data from certain studies regarding the prices of both of the supplements. And these databases I used are the Aquaculture Economics and Management Journal and the National Academy of Sciences of the United States of America. So after I got my data from these databases that were previously mentioned, I had to convert my units into something more similar because all of the databases use either percent concentration or milligrams per kilogram to measure their methane emissions. And in order to get everything into milligrams per kilogram, I had to multiply the percent concentrations by 10,000. And after they were all in milligrams per kilogram, I was then able to quantitatively compare them with one another to see which one would be more effective. So this was my first round of data, and as you can tell from the larger, the taller bars, that is the methane emissions of the cows who ate feed with none of the supplements in them, and they were the same. And as you can tell by the smaller bars, they show the methane emissions of the cows who ate the feeds with the different concentrations of supplements in them. And as you can tell, the cows who ate the feed with the algae supplement in them produced much lower amounts of methane compared to that of the 3-NOP cows. And this was my second round of data, which showed the prices of each of the supplements per kilogram. And as you can tell, there's an extreme difference in the size of the bars because the Asparagopsis texiformis also only cost around 18 cents per kilogram, which was extremely inexpensive. And the 3-NOP cost over $4.8 million per kilogram, which is extremely expensive compared to the Asparagopsis. So after analyzing my data, I found that the Asparagopsis texiformis was the obvious more effective supplement compared to the 3-nitroxypropanol. And this was due to the fact that it had a much higher methane reduction rate at over 86% compared to the 3-NOPs, which was 26%. And it was also much more inexpensive compared to the 3-NOP because it was only 18 cents. So as I went through my research, there were some limitations that altered my methods. And one of these was that it was really difficult to determine the price of the 3-nitroxypropanol supplement. And that's because it's such a newly discovered chemical that hasn't really been used in that many studies before, and it was really kind of rare to find it online. But I did overcome this by researching using the different chemical names for 3-NOP, and I was able to find on Apex Bio the price for the supplement. So and now that we know that Asparagopsis is the most effective supplement compared to 3-NOP and all other algae, people can definitely start to purchase this supplement and use it in their livestock feeds in order to reduce methane emissions at a very high rate, but also not cost as much or cut into their budget. And it's actually been found that Asparagopsis has a tendency to wash up on the shores of the Mediterranean Sea, and especially in Greece and Egypt. And the fact that they are so abundantly washing up is very good because people don't always have to buy it, they can actually just collect it off of the shores. So now that we know that both of these supplements have been tested and proven to decrease methane emissions, and we know that Asparagopsis is the most effective supplement, there are many things that can be studied to ensure it is the best supplement. And the first one is that we can see the incentive for farmers to want to buy this product. And that's because people don't always want to buy it just because it has a low methane reduction rate. They'll need something that will make their profits go up, which could be the fact that it could increase their milk production, it could be very good for the farmers. And the second thing we can study is the environmental impacts of this supplement, because the cows will be ingesting and digesting this and excreting it into their surrounding environment, and you don't know if it's going to impact the environment positively or negatively or have a negligible effect. And the last thing we can study is the impact of this supplement on cows' overall health, because the cow is the test subject, which is the most important part of this research. And you don't know if once they ingest it, it's going to be positive towards their health or negative or have no effect, which is the most important thing because the cow is the test subject.
Thank you, Delaney.
What was one challenge you encountered while performing the research, and how did you address it?
Well, during my research, the one problem I ran into was that I wasn't able to find the price of the 3-nitroxypropanol supplement, and that's because it was such a newly discovered chemical that hasn't really been used in that many studies before. So I wasn't able to find it, and it was really hard. But after a while, I found the different chemical names for 3-NOP, and I was able to research using those, and then I finally found the price for it on Apex Bio.
Which of the various perspectives that you explored was the most difficult for you to incorporate into your research inquiry, and why?
Well, during my research, the most difficult perspective to incorporate into it was probably the economic perspective, again, because I wasn't able to find the price of the 3-nitroxypropanol supplement because it's such a newly discovered chemical. But I was able to overcome this by researching the different chemical names and finally finding the price for it.
Which of your sources was the most influential, and in what way is that influence apparent in your final conclusion?
Well, the source that was probably the most apparent or important in my research was the study done by the American Journal of Plant Studies, and that was when they compared the methane reduction abilities of all the different algae in their feeds, and that found that Asparagopsis was the most effective compared to the other algae by far, and that was really apparent in my solution because it wasn't only much better than the other types of algae, but it was better than the 3-nitroxypropanol.
Thank you.
Thank you.
Thank you.